There's an object from another star system in our neighborhood, and it's acting really weird.
So, could this visitor, 3I Atlas, actually be an alien probe? One top scientist thinks it might be. And get this, he says NASA is sitting on the high-res images that could prove it. We have the public pictures from Hubble, but the really good ones are from the Mars Reconnaissance Orbiter. And those unreleased images? Yeah, they're about 3 times sharper than anything we've seen. So why haven't we seen them? Well, it all comes down to some really unfortunate timing.
The orbiter snapped the pictures on October 2nd. The very next day, a government shutdown hit NASA.
As Professor Avi Loeb says, politics really shouldn't get in the way of major scientific discovery.
But even without those photos, what we do know about 3I Atlas is just plain bizarre.
There's a whole list of weird things about it that just don't add up.
For starters, as it got close to the sun, it got way, way brighter than a normal comet should.
And its color means it's super hot. But at that distance, it should have been much, much cooler.
Something besides gravity is also pushing it around, which is a huge red flag for scientists. It was shedding nickel with almost no iron, a mix you sometimes find in industrial alloys.
Even weirder, it had a jet of material pointing towards the sun, not away from it.
And if all that wasn't strange enough, let's talk about the sheer size of this thing.
It's estimated to be 1,000,000 times more massive than Oumuamua, our very first interstellar visitor.
So you have a mysterious object, withheld images, and a pile of scientific oddities.
When you add it all up, some scientists have to ask, is this thing even natural?
But without those high-resolution NASA images, the biggest question of all remains unanswered. Is this just a bizarre comet, or could it be a clue that we're not alone out here?
Welcome to The Debate. Our discussion today, well, it focuses on 3I Atlas, this massive Manhattan-sized interstellar object that's currently moving through our solar system. The source material highlights a really critical tension. This object, it shows a whole catalog of physical and orbital traits that frankly defy typical cometary physics, yet access to maybe the single most crucial piece of data we could get, high-resolution images taken near Mars, well, it remains restricted.
Right, and the core question for us is exactly that procedural paradox. Does this accumulation of really highly anomalous data, about 3 Atlas data, suggesting it might be, something not quite natural, does that create a scientific imperative that's so immediate, so overwhelming, that it really demands the prompt release of those high-resolution images from the Mars Reconnaissance Orbiter, the MRO, essentially overriding standard data release protocols and, well, institutional delays?
Look, my position is pretty unequivocal here. The unprecedented nature of these observations, particularly the thermal and chemical signatures we're seeing, it dictates that this critical MRO spatial data must be released immediately to the global scientific community. We need this information now to formally test the hypothesis of artificial origin and, just as importantly, to design the necessary timely follow-up observations before this thing moves too far away.
I come at it from a slightly different angle. While that MRO data is, yes, undeniably necessary for structural analysis eventually, I'd argue that the current set of anomalies, though startling, definitely startling, they don't yet confirm artificiality, and they don't justify overriding established rigorous data handling protocols just based on what really amounts to speculative urgency. Scientific rigor demands we follow the process even for the most compelling subjects.
The current evidence surrounding 3I Atlas, it just fundamentally goes beyond the behavior of, familiar comets. Let's consider the thermal and spectral facts again. The object became extremely bright, much more than expected, okay? And most compellingly, it's bluer than the sun. Now, this implies an object at that distance is somehow maintaining a temperature profile or maybe a reflectivity that fundamentally defies expected thermal physics. It should be something like 20 times cooler and significantly redder out there. And then, compounding this, we now have the first, let's say, confirmed hint of non-gravitational acceleration, meaning its path is being affected by something other than just gravity. So the MRO camera took images back on October 2nd when the object was closest to Mars. This gives the scientific community a chance for the closest spatial analysis yet.
When you're dealing with a phenomenon of this potential magnitude,
one that seems to contradict multiple laws of expected physics all at once. Well, administrative inertia, like the reported government shutdown delay, it just cannot be allowed to impede operational science. This MRO data is essential for scientists to constrain their models and design those crucial future observations to track its potentially deviating path.
Okay, that's an interesting point about the operational necessity, though I would perhaps frame the nature of these anomalies a bit differently. I readily concede 3 Atlas is highly unusual. It's massive, you said it, 1,000,000 times larger than Oumuamua. And it possesses this unique chemical profile. It showed nickel with very little iron. Some analysis has likened this to highly fractionated, almost industrial-like production. We absolutely have to grapple with these facts. However, these facts, both individually and yes, collectively, they really must first be viewed through a framework that accounts for unique, maybe extreme, or just unexpected natural compositions that can arise from interstellar space, before we leap to the conclusion of artificiality. For instance, non-gravitational acceleration, or NGA, it's actually a common phenomenon in natural comets. It's caused by the jetting action of vaporizing ices pushing the comet slightly off its purely gravitational path. So while the NGA seen here might be unusual in its magnitude or duration, it isn't inherently a signature of technology. And furthermore, the source material did note the data delay coincided directly with institutional downtime, which suggests a procedural bottleneck rather than, deliberate concealment. Scientific integrity requires that controlled release, the calibration, proper archiving, all to ensure data quality.
I see why you emphasize the established protocols. I do. But let's press on the true scientific core of this dilemma. Specifically that blueness anomaly. Why does this thermal signature demand we prioritize the MRO images? The sheer physical deviation of being bluer than the sun, it means the object is either radiating much hotter than it should be, or its surface composition is reflecting light in some entirely unknown way. This fundamentally challenges our models of expected interstellar body composition. We need the MRO's spatial view to check for geometry, maybe rotation, or localized surface activity. Jetting, perhaps? That could explain this extreme temperature profile.
I have to push back on that assertion a bit, because it seems to conflate the urgent need for spectral data, which tells us about temperature and composition, with the questionable utility of the MRO spatial image in this specific context. While the blueness is indeed a serious anomaly, yes, the MRO images, remember, were taken at a range of 30 million kilometers. They offer a spatial resolution of only 30 kilometers per pixel. Now, if 3 Idalis is, as described, merely the size of Manhattan, maybe 10 kilometers across, that image is going to yield only a few pixels across the object. At best, what specific, high-level structure, what truly conclusive evidence of artificial geometry or internal processes do you genuinely expect to resolve at that very low resolution that justifies circumventing months of established, careful protocol? It almost feels like operational panic, based on spectral anomalies that MRO, as a primarily spatial instrument, cannot immediately clarify.
That line of reasoning challenges the practical utility of the data, which is, okay, that's a fair point. However, even if the image is only a handful of pixels, that morphology, just the shape or brightness distribution, can be sufficient to constrain major structural hypotheses. For example, if the body exhibits a highly regular geometry, maybe elongated or faceted, or if light curve analysis suggests an anomalous, non-tumbling rotation that aligns with the detected NGA, well then this low-resolution spatial data becomes indispensable. If the blueness is caused by persistent localized jetting, say from a single dominant vent, even a few pixels could potentially resolve that asymmetric activity. The MRO image isn't the final answer, of course not, but it's a critical constraint we lack right now to inform better planning for instruments that do have higher resolution or superior spectral capabilities.
Okay, I can conceive that the spatial image, however low resolution, might offer some constraints on morphology. But let's pivot maybe to the chemical evidence, which is arguably even more provocative than the blueness, yet sometimes gets downplayed in this rush for images. We really should discuss the nickel and low iron signature. You use the term industrial-like. Let's maybe define what that implies for listeners.
Right. That's a critical distinction. The nickel-iron signature is, well, profound, because in natural celestial mechanics, elements like nickel and iron are usually found together, bound up in chondritic or metallic matrices. An industrial-like signature implies highly fractionated material, meaning these elements were subjected to processes, likely thermal or chemical, that very efficiently separated the volatile components from the refractory ones, leaving behind a highly pure, unique mix that is just very difficult to produce through typical planetary or solar nebula formation processes we know about. It does suggest potentially intelligent, large-scale processing of materials.
I appreciate that concise summary of the artificial hypothesis. However, while we certainly see this kind of fractionation in industrial settings on Earth, to immediately link it to technology, well, it overlooks the possibility of extreme natural fractionation occurring in highly energetic or unique interstellar environments, perhaps near a white dwarf, or in a very specialized type of protoplanetary disk we haven't really categorized yet. We are dealing with an interstellar body. By definition, its formation history is already outside our normal reference frame of solar system comets. We just can't dismiss the possibility that it represents an extreme outlier of natural chemistry that pushes the boundary of our current compositional understanding.
I agree. We must be careful not to fall victim to a kind of God of the gaps argument. Substituting a technological explanation for anything we can't immediately explain naturally. But the cumulative nature of these profound facts argues strongly against just treating 3.8 Atlas as merely an extreme outlier. You have the massive size, the industrial-like chemical signature, the bluer-than-the-sun thermal profile, and now this hint of non-gravitational acceleration. When multiple independent lines of evidence all point toward an object behaving outside the defined natural envelope, the credibility of the technological hypothesis, well, it increases significantly. And that makes the prompt release of the highest quality spatial data we have a necessity for rapid falsification or possibly verification.
But I must challenge the premise that just cumulative strangeness justifies disrupting the procedural timeline. You noted the NGA is a key factor creating urgency, but let's remember NGA is a dynamic factor. If we compromise the calibration process by rushing the MRO data, which again is low resolution and was taken weeks ago, we risk introducing uncertainty that propagates into future orbit models. The delay, which seems linked to institutional staffing issues during the shutdown, is fundamentally about ensuring data integrity. If we release uncalibrated, rushed data merely to satisfy public and, let's face it, speculative pressure, we risk drawing scientifically premature conclusions based on flawed inputs, and that jeopardizes the very foundation of the eventual conclusion, whether it turns out to be natural or artificial.
But that perspective, I think, overlooks the operational imperative tied directly to the NGA. If the object's trajectory is actively changing now, then every day of delay directly impacts our ability to design necessary follow-up observations to track that deviation and figure out its underlying cause. This isn't just about satisfying curiosity, it's about optimizing observation windows before the object moves too far out of range entirely, or maybe before whatever mechanism is causing the NGA changes or stops. The MRO images, being the closest look we've had, are essential for characterizing the potential source of this acceleration, whether it's large-scale venting or something else entirely. We risk losing crucial observation time if we wait months for the full procedural archiving.
While the operational window is certainly a valid concern, the alternative is potentially releasing data that we cannot fully trust. The rigor of science, it demands that we maintain control over the data chain. The scientific community needs verifiable, controlled, and properly calibrated data to analyze this object's structure and constrain its trajectory, regardless of how sensational the hypothesis might be. We really must allow the proper channels to verify the NGA finding, cross-reference the spectral data, and release the spatial data under controlled conditions, ensuring we fully understand the limitations and calibrations of what we are actually seeing spatially. That deliberate, careful approach maximizes the chance of arriving at the real truth, whatever that truth may turn out to be.
My core position remains that the fundamental scientific question is 3i Atlas something not quite natural, is profoundly informed by the simultaneous failure of multiple physical expectations. Its industrial-like chemistry, its bluer-than-the-sun color, its sheer mass, and this indication of non-gravitational acceleration. The MRO data is the single most critical, proximal piece of evidence currently available to help constrain the structural components behind these anomalies. This collective weight of evidence, for me, makes its prompt release a scientific necessity that simply transcends administrative inertia and perhaps overly cautious speculation.
And I conclude that the scientific community undoubtedly needs the MRO data, yes, to analyze the object's structure and constrain its trajectory. However, the rigor of scientific interpretation must not be compromised by speculative urgency or, frankly, the rush to confirm a particular narrative. Our goal has to be the complete and rigorous understanding of this object, whether it's an extreme outlier of natural formation or something entirely artificial. And that requires a careful, controlled analysis process, not procedural shortcuts based on claims of hidden data or immediate necessity driven by hypothesis alone.
Precisely why 3i Atlas continues to be one of the most intensely monitored objects in recent astronomical history.
Indeed. It remains perhaps the most compelling and perplexing interstellar object encountered to date.
And it demonstrates perfectly the value of seeking multiple, rigorously tested perspectives when confronting such complex and unusual phenomena in the material.
Okay, so we're looking at this piece critiquing the claims around 3i Atlas potentially being alien tech, and also that whole issue with NASA supposedly holding back data.
Right, the high-res images specifically.
Exactly. We picked out 3 main areas in the structure where we think some tweaks could really boost the impact.
Sounds good.
All right, let's jump right in. First up, completeness and focus. We felt the material, well, it struggles a bit to keep a clear focus because it's presenting 2 really compelling narratives side by side.
The science anomalies and the NASA data thing.
Precisely. You've got the weird science of 3i Atlas, its huge mass, the nickel, the jet, the polarization, and then you have this urgent political controversy about the MRO images.
And they're treated almost equally right now?
Yeah, that's the weakness. By giving them sort of equal weight, the piece kind of dilutes its own punch. The reader is constantly switching gears, between complex physics and this skepticism about NASA.
I see that. It splits the narrative energy.
Exactly.
Okay, so what's the fix? I think the core structural issue is needing to unify those threads, right?
Yeah.
We probably need to structure the argument, so the whole political thing, the dispute over the NASA data, those MRO images near Mars, the really high-res ones, feels like a direct result of the science.
A consequence, almost.
Exactly. A logical consequence, or maybe an urgent need that's established by the weird science you've already laid out. Right now, they feel a bit like 2 separate stories running in parallel.
Okay, so how do we connect them more strongly?
Well, I'd suggest really prioritizing the scientific case first. Like, build up the evidence that 3 Atlas has already shown all this anomalous behavior you mentioned, the jet, the hints of non-gravitational acceleration.
Right.
Emphasize that first. Then, frame getting those MRO images as the absolute critical next step scientifically. It's the only way to move forward given what we already suspect.
Ah, I see. So the political delay, the data not being shared, maybe because of the government shutdown, messing with release schedules or whatever, that becomes less about general bureaucracy and more about a direct block to understanding something potentially huge.
It elevates the stakes of the missing data. It's not just transparency anymore, it's obstructing science.
Okay, so concretely, maybe don't bring up the MRO data controversy right when you first mentioned, say, the weird blue color.
Yeah, exactly. Hold back on the details about the missing 30 kilomegapixel MRO images until after you've really sold the idea that the existing evidence points towards something potentially artificial. Then, when you reveal the data is missing or delayed, the audience feels that lost opportunity much more acutely. They understand why those specific images are so damn important.
Okay. I was just wondering, though, do we maybe lose some initial hook by delaying that? Doesn't the NASA withholding data angle grab people right away?
That's a fair point. You don't want to lose urgency. But I think the kind of urgency changes and it becomes more powerful.
How so?
Well, you're shifting from a sort of general frustration with red tape or maybe even conspiracy thinking
Right.
to a very specific high-stakes scientific disaster. If the reader starts out thinking this is just another weird comet, the MRO delay is annoying, maybe, but easily dismissed. Bureaucracy happens.
But if they're already leaning towards this might be technology,
Then the delay is potentially catastrophic. It's stopping us from confirming or refuting something historic. That's a much stronger narrative position, I think.
I see the rhetorical power there. Yeah. Trading that early, maybe slightly shallower outrage for a deeper, more informed sense of urgency later on.
Precisely. You need the reader invested in the content of those missing images, not just the politics around them being missing. The science has to create the demand.
Okay, that's a really useful reframing. So if we're leading with the science, making sure that hits hard is key. Which brings us nicely to our second point, actually.
Good transition.
It's about angle and significance. Specifically, that really weird recent finding about the color. We felt the piece kind of underplays how scientifically bizarre it is that 3 is bluer than the sun and surprisingly bright.
Ah, yes, the thermal contradiction.
Exactly. The weakness here is how quickly it's presented. You mention the blue color, then immediately jump into the physics. Blue means hot, but it should be way cooler than the sun. At that distance, like 20 times cooler, so it should be redder.
Right, it gets technical fast.
Too fast. Before the reader can really absorb just how fundamentally weird that blue color is for something like a comet out there. And the fact it got extremely bright, way brighter than expected, that gets buried instantly under the comparison of the sun's temperature, the 5800 Kelvin thing.
Yeah, the wow factor gets lost in the explanation.
Totally. You lose the awe.
Okay, so building on that, we definitely need to treat that blue color like a major reveal. It just flies in the face of basic expectations for objects heated by the sun.
So the suggestion?
I think we need to isolate it more, amplify that blue color anomaly. Frame it as maybe the strongest and most accessible current piece of evidence suggesting something non-natural. It's scientifically sharper, more immediate maybe, than some of the older accumulated evidence. It's a direct thermal puzzle happening now.
Okay, amplify it. How?
Well, first, you've got to really set the stage. Establish the baseline expectation clearly. Spend a moment saying, look, anything this far from the sun gets very little heat. Standard physics, standard comets, they should look cool, dull, and distinctly red.
Hammer home the should-be red part.
Exactly. Make sure the listener understands the rules before you show how this object breaks them. Paint a clear picture of what we expect to see.
So establish the expected. Red, cool, dim. Then bam, hit him with the reality. It's bluer than the sun and way too bright.
Precisely. That contrast is what gives the claim its power. Because if it is bluer than the sun, and if that implies a really hot surface, well, that suggests something truly strange is going on.
Like either it's reflecting sunlight in some impossible way.
Or, and this is the really provocative part, it has some kind of internal heat source, which for an icy rock makes no sense in conventional physics. That contradiction needs to be front and center.
Yeah, I can see how that really dials up the strangeness. And this loops back to our first point too, doesn't it?
How so?
If the blue anomaly is that dramatic, that physically impossible seeming, it makes the demand for those high-res MRO images even more urgent and justified.
Absolutely. It changes the framing again.
It goes from, we need the data to check our theory, to something more like, we need the data because reality seems to be broken right here.
Yes, that's the narrative arc. The blue anomaly becomes the immediate present-day scientific driver. It makes the whole investigation feel current and rapidly evolving, not just like recounting old weird observations.
Right, not just a history lesson. Okay, that feels much stronger.
Good.
So that brings us to the historical stuff. Our third and final point is about how that older evidence is organized. It's about structure and flow.
Okay.
I mean, it's clear you wanted to show a pattern of strangeness by listing all the previous discoveries, which is good. But the way it's done currently, this sort of rapid-fire listing, it lacks a bit of synthesis. It doesn't quite build that cumulative case for suspicion as strongly as it could.
So the weakness is the listing format itself.
Yeah, pretty much. You list the facts, it's in the plane of the planets, it's massive, 1,000,000 times Oumuamua, the nickel detection, that jet, the polarization data, and it feels like reading bullet points off a timeline.
Chronological rather than thematic.
Exactly. It doesn't group them in a way that shows why these different facts, taken together, steadily increase the probability that this isn't natural. It doesn't feel like a clear chain of reasoning leading to the alien tech hypothesis. More like just a list of weird things.
Got it. That makes sense. We want the reader to feel the combined weight of these different anomalies pushing towards one conclusion. This thing is weird in multiple, independent ways.
Right.
So the suggestion here is pretty straightforward, I think. We need to move beyond just listing them chronologically. Group the historical anomalies logically. Create, maybe, thematic buckets of strangeness.
Buckets of strangeness, I like that.
Yeah. It helps organize the evidence and shows a clearer, more structured thought process. It builds the pressure more effectively towards the idea of technology.
Okay, so what would these thematic buckets look like? Give me an example.
Okay, well, you could create one theme around, say, composition and structure.
Okay.
Under that heading, you link the fact that it's very massive, huge compared to Oumuamua, with the detection of nickel with very little iron. The piece already notes that this nickel signature is suggestive of industrial alloy production, right?
Yeah.
So grouping those together isolates the evidence about what the object is made of and its scale. The argument becomes it shouldn't be built like this naturally.
I like that. It pulls related facts together. What about the other anomalies, like its movement?
That's your second theme, motion and dynamics.
Okay.
Here, you connect its weird orbit being in the plane of the planets, which is unusual for an interstellar visitor, with the observed jet towards the sun, and those hints of non-gravitational acceleration.
Ah, so one bucket for what it is, one for how it moves.
Exactly. This structure makes it much clearer why these older facts are relevant and make the object, as the piece says, even more interesting than it was before. You're showing evidence that it's both built strangely and moves strangely. That builds a much stronger foundation for the non-natural hypothesis before you even get to the latest shocker with the blue color.
That grouping feels much more powerful. It's not just, here's a list of weird stuff. It's, here's a pattern across its physical nature and its behavior. That synthesis really gives the argument more backbone.
Yeah, solid structure. And it also helps the reader digest the information. They're not just getting hit with fact after fact. They're processing them in logical chunks, which is crucial when you're talking about something as potentially groundbreaking and frankly sensitive as alien technology. Your groundwork needs to be rock solid.
Absolutely. Wow, okay, this has been really helpful. We've covered quite a bit on structure, focus, and really making the key scientific points land harder. Let's just quickly recap the main actionable suggestions.
Sounds good.
All right, first, realign the overall focus and structure. Make the weird science of 3 at lattice the clear reason why the MRO data is so critical. Don't treat the science and the politics like separate stories. The science has to drive the demand for the data.
Right.
Second, really isolate and amplify that bluer-than-the-sun anomaly. Make sure you set the expectation of what should be seen first, red, cool, to maximize the impact of the thermal contradiction. Make that the immediate, gripping scientific puzzle.
Makes sense. And third, organize that historical evidence. Ditch the chronological list. Group the anomalies into thematic buckets like composition structure and motion dynamics to build a stronger, cumulative case that points towards something non-natural before you hit the current blue anomaly.
Excellent. Those 3 shifts should make a significant difference.
Yeah, I think this piece has huge potential, and tightening these structural and emphasis points will really help it connect with maximum force and clarity. We definitely encourage you to work on these points and, feel free to send the revised version back for another look.
Great stuff. Thanks for tuning into this critique.